So I just shortened the last video so you guys can take your time doing the problems. And now in this video, I'm just going to continue with some multiple choice on limits and continuity. So I hope you guys enjoyed this video. In this next example, it was actually a part of the calculator problem, but because it was number 77, but there was no calculator necessary. So let's take a look at it. Well, if you guys remember from our limits video, the limit as x approaches a number from the left means you're coming from here. A limit as x approaches something from a function from the right means you're coming from this way. Now, the limit from the left and the right could exist without the limit actually existing. That means if the two numbers went to different numbers, then that limit wouldn't exist, but their left-sided and their right-sided limit would exist. So let's take a look at this. It says, the figure above shows the graph of the function with domain from 0 to 4. It's a closed interval. Which of the following statements are true? The limit as x approaches 2 exists from the left. And that is absolutely true. Let me show you why. Okay, so a couple of things. Here's 2, right? I'm going to go like this. Okay, and now what I'm going to do is I'm just going to go exaggerate from here, and I'm going to exaggerate from here, okay? So with that being said, I'm going to call this guy, who knows, 4, this guy 2, I don't know. All right, so the limit as x approaches 2 from the left goes to this number 4. The limit as x approaches 2 from the right, that goes to this number 2. So these two guys work, but number 3 doesn't work because they're going off to two different numbers. So number 1, the limit exists from the left, from the right at 2, but not at 2, which means it's not continuous. And you can obviously see there's a jump discontinuity, okay? So which of the following are true? 1 and 2 only. So that was pretty simple, all right? This was, again, from 2008. All right. The horizontal line y equals 2 is an asymptote. Which of the following statements must be true? Well, horizontal asymptotes is basically what happens at the very end of the graph. Not in the center of the graph, but at the end. The limit as x approaches infinity of the function, what happens to it? Well, if it went to 2, that means that there's a horizontal asymptote at y equals 2. So, which of the following functions or which of the following statements must be true? F of 0 equals 2. Which of must be true? Okay? This is the definition of a horizontal asymptote. You can pause the video and look at all the problems, but this is what has to be true. F of 2 is we don't care about f of 0, f of 2, and so on, because asymptotes, for horizontal asymptote, this is what we care about. It's the end behavior. Great. Speaking of end behavior, what is the limit as x approaches infinity? Well, infinity, again, you got to take the highest on top. That's x to the third. Be sure to look at everything. 4x to the third. Be sure to look at everything for the highest, because sometimes they don't write the highest in the beginning. So we get x to the third, 4x to the third. It reduces to 1/4. And so basically, just bouncing off the question above it, the limit as x approaches infinity is 1/4, which means that there is a horizontal asymptote at 1/4, okay? So let's try the next problem. And this will be, I think, our last multiple choice question, okay? The graph of the function f is shown above. At which of the values of x is f continuous but not differentiable? Okay. I know that it's not continuous. It's not continuous at b, and it's not continuous at d. So b is gone, d is gone, okay? E, C, and A. Well, I know we don't know about derivatives. However, I just want to talk to you for 2 seconds about it. E is great and C is great. A, we have a problem. A is a problem because there's a sharp turn. In our next video, we're going to start talking about, in our next chapter, we'll start talking about derivatives, and you'll understand why the answer is going to be A. Some of you probably already know about derivatives and understand that it's A. you can't have a sharp turn like that. It will not be, it will be continuous but not differentiable. The derivative doesn't exist there. So the answer is going to be A. Sorry I couldn't give you guys a better explanation at this time, but that's because my videos are going in order and I haven't gotten to derivatives yet.